Let us start off with electrostatics.
Yes, sir.
Now, this is basically the beginning of, we can say, modern physics, in the sense that the Newtonian mechanics that we have done is there since a lot of years. But whereas the study of electric fields and magnetic fields is a recent one relative to the Newtonian physics. Okay.
Yes, sir.
Which in some way is also fun to learn about. So let's see. Okay, but let us start off with the basic things in which usually people have the problem. Okay,
Yes, sir.
this, we see, what we can do is we can understand the concepts in a very brief manner, but because we have time, first we will go according to generally how it is taught, and then we will, after 15 or 20 days, in one lecture, I will give you a cumulative understanding of what entire electrostatics is.
Yes, sir.
In one lecture only it can be done, but because it is very new and all, let us begin from the very right from the very start.
Yes,
Now,
sir.
till now we were dealing with masses, only masses, I mean. Momentum is mass into velocity, angular momentum is mvr or mr square omega, or we have force, torque. All of these are basically around mass. We are only interested in the mass perspective. Now we are beginning to understand the charge perspective. Okay, because of
Yes, sir.
our previous education, we already know there is something called electron, there is something called proton. The difference between electron and proton, apart from mass, is that electron has a positive and negative charge, proton has a positive charge, right?
Yes, sir.
So therefore we have heard the word charge. Okay, so we can start off right from there. Let us not dig into what is charge and what is mass. These two are very fundamental questions,
Yes, sir.
which later on in our leisure time we will have a discussion of what is mass, what is charge, and all. So, taking something as charge into account, you already know in your school, like charges repel each other, unlike charges attract each other,
Yes,
right?
sir.
So, we start off first with point charges. Okay,
Yes.
so the Coulomb's law is the beginning, at least from where we start off in our, okay, whatever, Coulomb's law. I wrote the spelling wrong, I think there is no O over here, probably. Starts off with point charge, and then we go into distribution of charges. So let us two point charges placed at point A and B, and let us say this charge is plus q1, the charge over here is plus q2.
Mm.
Here, let me define the position vector of B with respect to A as r bar, small r bar,
Yes, sir.
where the magnitude of this can be written as small r.
Hmm.
Okay, so basically we can say that the distance between points A and B is r, or in terms of vectors also we can say that
Maybe bar.
is equal to r bar, which is r into r cap. We can write it like that also, right? R is the magnitude into r cap.
Hard cat. Yes, sir.
We can write it like this also. So the whole idea is the unit vector representing the direction from A to B is r cap, which is nothing but AB cap.
Hmm.
Okay.
Yes, sir.
Now, according to Newton's law, the force between two charges q1 and q2 is given by 1 by 4 pi epsilon naught if these two charges are placed in free space. What do we mean by free space? That means not like atmosphere.
Hmm.
What I mean is that we are not placing the charges here because there is air in between. Neither are we placing the charges in oxygen, nitrogen, or anything. Literally, there is
In
nothing
vacuum.
over here, is what we call as free space. Okay,
In vacuum, sir.
in vacuum, basically, we can say, right?
Yes, sir.
Where there is no material, is what I exactly mean. Where there
Hmm.
is no material, which is basically vacuum. So the force of attraction or force of interaction, we'll say, is basically 1 by 4 pi epsilon naught into the force is proportional to the product of the charges divided by the square of distance between them. That means what Newton basically said is that this force is proportional to product of charges and inversely proportional to square of distance between. This is Coulomb, what Newton, not what Coulomb basically
Sir, so that proportionality constant is 1 by
1
4
by 4
pi.
pi epsilon naught, which we usually denote it by K. And the value of K is 9 into 10 to the power 9, some SI units. We can get the units from books. Okay. We can get it by solving also. Okay.
Yes, sir.
The value of this K fellow is. Now, what is this epsilon naught? Epsilon naught is called the permittivity of free space.
What is permittivity, sir?
Good question. That's the reason I enjoy your lectures, because you ask the questions. Usually people don't ask. The main problem where people face in electricity and magnetism is to understand what this permittivity is, which I will explain slowly as the lectures go by.
Hmm.
My first agenda is to make sure that you are able to solve the problems with understanding of vectors and everything and the physics in it. My ultimate goal is to make sure to explain to you what is this permittivity.
Yes, sir.
Right now, I will say what permittivity is. Permittivity is the physical quantity which is enabling this force of interaction between the charges.
Yes, sir.
In gravitation, in school already you have seen in ninth or 10th, there is a capital G, universal gravitational constant. That gravitational constant is the physical quantity upon
That
which, based on which, the force of interaction is defined,
yes, sir.
or the force, basically the force of interaction is occurring through this particular medium. I
Yes, sir.
always say think of physics in terms of layman, because that is how we will realize how any of the scientists actually came up with these laws.
Hmm.
Suppose two people are fighting. You know, one fellow is applying force on the other fellow because you can see that fellow physically getting in contact with the other fellow.
Hmm.
Boxing, let us say, you can physically see that there is a contact. So, as laymen, let's say Stone Age people, it is easy to understand that the force applied by Muhammad Ali on, let us say, Mike Tyson is through his hand. But the
Yes, sir.
but the biggest question is, How can a Stone Age person understand there is nothing in between Q1 and Q2, but there is a force of interaction existing? He will say impossible. Q1 has to somewhere go and touch the Q2, right?
Yes,
So
sir.
this force of interaction is occurring through this medium, which doesn't have any material. It is a materialless medium which has a property of itself called permittivity, which is enabling these interactions to occur.
That permittivity is responsible for getting the charges closer.
Hmm. Getting the charges close, let the charges be fixed. They are not going closer or farther, let's
I
say.
mean, the force of interaction in between.
Permittivity is responsible for the force of interaction to exist in the first place. Permittivity is basically a property of that particular medium, irrespective of the material it has. It has no material, we are saying permittivity.
Hmm.
So, what does, in terms of material, how do we write it? We write, so this is in free space, whatever we have discussed, right?
Yes, sir.
We write in a material medium, yeah?
Material medium is free space. Sir, it is not.
No material medium is free space.
Yes, sir.
There is no material in that medium, in that space. We are calling it as free space. Material in the sense what? The elements that we see in our periodic table,
Okay.
they are not there. Simply when I say atmosphere, you already know it has oxygen, sulfur, phosphorus, whatever, everything, nitrogen, carbon.
Yes, sir.
All these things are there in our carbon dioxide, carbon monoxide, all these things are there in air, which we call as
Hmm.
atmosphere. So I am saying, think of it in terms of a layman perspective. One fellow will say, why air? Let me put only oxygen in one room. Then what will happen? It is also a material medium.
Yes, sir.
Let me put only hydrogen gas. That is also material medium. Now other fellow will say, why only gas? I want to use liquids. Let me fill a control volume. What we are
That is also made of elements only.
correct. If you fill it off with water, you have H2O molecules. If you fill it off with petrol, you have a lot of molecules,
Hmm.
carbon, hydrogen, all these. No elements of periodic table existing is what we are calling it as no material.
Hmm.
But there is a control volume on which in which we are studying all these things, that we are calling it as space, and because there is no material in that, we are calling it as free space. Okay.
Yes, sir.
But if there is material, then what will happen? Then there is something called permittivity. Still, we call it permittivity of that medium.
Hmm.
Permittivity of free space as a subscript epsilon naught.
Yes, sir.
Where there is material, we write it as epsilon.
Sir, in the Gibbs free energy, we have G naught because it's free energy. I mean,
Subscripts. No, 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 no. Wait, wait. We use nouns to call each other.
yes, sir.
Has nothing to do why we call dogs as dogs.
Yes, sir.
So, in material medium, permittivity is written as epsilon only, which is product of relative permittivity into permittivity of free space. So this relative permittivity has some values which, as we move ahead in chapters, we will see. We will eventually, we are not running away from
It is
this.
like with respect to something related.
First let me write it.
Okay.
So I am saying this is what actually there is, I think, double T over here. Permittivity of that particular material or medium, whatever. If there is material, then this fellow will come. But we will come to this fellow very later. Initially, we will be dealing with free space only.
Yes, sir.
Very, very later, we will come to this fellow. Initially, we will be dealing with free space only. Understanding permittivity, leave it to some 15-20 days.
Okay.
Understanding means, see, literally, I'll say, if you ask me what is gravitational constant, you've been looking at that capital G since your ninth class, 10th class.
Yes, sir.
Do you know what capital G is? Literally,
No.
physically. You just have a idea of what it is. That's why I'm saying understanding what this permittivity or permeability, leave it for some chapters to go by. Slowly, slowly, we both will come to the same plane of understanding little bit of what it is, not very thoroughly about it.
Yes, sir.
Just understanding what it is, leave it to later. First, we have to enable ourselves to solve problems.
Hmm.
Now, so leave this fellow here only. We basically deal with free space questions. Okay.
Yes, sir.
Now, where is the problem that usually people face? When I write the vector form, when I am writing the vector form, I have to also make some sense to it, right? So,
Yes, sir.
what I want to
To
write
have
is,
direction.
right, so force on B due to A is what I'm writing here. Okay. The
Hmm.
force on B due to A, force on B due to A in vector form, in which direction will it apply the force? Because these two are
Right
like
side.
charges, right side. That means along R cap.
Yes, sir.
So force on B due to A can be written as K. Magnitude is Q1 Q2 by R square. Magnitude is okay. I
Into
have to
our
put
cap.
R cap. Correct?
Yes, sir.
Suppose I want to write force on A due to B
Minus R.
minus R cap. Simple. Is this clear?
Yes, sir.
Very simple. Don't complicate it in your head. People complicate it. That's why I'm saying. Simply, due to A on B is towards right side, due to B on A is towards left side. Simple.
Hmm.
Because they are both positive charge. Clear?
Yes, sir.
So let us
Yes.
take the charge as 5 into 10 power minus 6 coulomb Q1, which usually we write it as 5 microcoulomb. Okay. Micro is 10 power minus 6. Right?
Yes, sir.
Let us take Q2 as 10 into 10 power minus 6 coulomb, which is 10 microcoulomb. Let us take the distance as 1 kilometer, which is 1000 meters. Okay, and K value, anyways, we know that it is K is nothing but 9 into 10 power 9 SI units. So
Yes.
find this is the first question. So find force on B due to A and take this direction. Usually we take it as I cap, right? X axis.
Hmm.
Take the direction as I cap, substitute in that and tell me what it is.
Okay. 4.5 into 10 power minus 8.
Minus
8.
minus 4, right?
Minus 4. Yes, sir.
Now I'll change the values in the sense that I'll change the sign of one of the
Into I caps.
I'll change the sign of one of the charges. Okay, so let's take Q1 is equal to 40 microcoulomb, Q2 is equal to minus 40 microcoulomb, and R is equal to 2 kilometers. And by the way, what in the answer of the previous question you said minus I cap.
I cap.
I cap. So here we'll get minus I cap, right?
Yes, sir.
Second question. Second question.
Yes, sir.
Ten power minus
Square
7.
into 10 power minus 3.
It is R square. In the previous question also it is 10 power minus 7.
Oh. I took it divided by.
I also took it. So here, yeah.
Yes, sir. Minus 1. I wait. 3.6 into 10 power minus 6.
3.6 into 10 power minus 6 newtons, right?
Yes,
And
sir.
it is minus 3.6 into 10 power minus 6 I cap.
Yes, sir.
Minus 3.6 into 10 power minus 6 Newton I cap.
That minus is from the Q2.
Correct. So it is minus basically, right? Now, third question.
Sir,
Yeah.
it got stuck. I mean, it's fine now.
Yeah. Okay. Now let us find force on A due to B in terms of I cap, minus I cap, whatever. Okay. I'll just give you the values. Q1 is equal to minus 30 microcoulomb. Q2 is equal to plus 60 microcoulomb. And distance, magnitude of distance between them is, take it as 300 meters.
54 into 10 power minus 3 I cap.
54 into 10 power
minus 3.
minus
Yeah.
3, and it is plus I cap, is it?
Yes, sir.
Okay.
I mean just minus I.
No, is it? What is the direction? Plus I cap or minus?
Plus I cap.
Plus
Plus
I
I
cap.
cap.
Let me do. I didn't do it. So 9 into 10 to the power 9 into Q1 is. I don't want to put any minus 30 or anything like that. I will only substitute the numbers over here, magnitude over here. 10 power minus 6 divided by r square is
Why you think
300.
R square? Sir, advocating R square. Okay.
So 130 will cancel over here. So let me write it again. 9 into 10 power 9 into. This is 300 into 300 I can do. So 130 will cancel over here. And I will have 110 in the denominator. Another 30 will cancel with this fellow. And there will be another 10. There will be 2 over here into 10 power minus 12. Is this correct? This is 300 into 300. So 30 by 300 will be 1 by 10. Another 60 by 300 will be 2 by 10.
Yes, sir.
And 10 power minus 6, 10 power minus 6, I am doing it as 10 power minus 12. So 18, right?
Yes, sir.
Into
18 into
10
10.
power minus 3 and minus 5 Newton. Correct?
Yes, sir.
Minus
Minus
3.
Yes, sir.
Now I want to understand the direction part of it. So what I have done is that I have taken the left fellow as the negative charge and the right fellow as the positive charge, right? So I want to understand the direction part of it. So this is a negative charge. This is a positive charge. Unlike charges, attract each other, correct?
Yes, sir.
So the negative charge is pulling the positive charge and the positive charge is pulling the negative charge.
Yes, sir.
So the force on B will be right to left, pulling.
Yes, sir.
Whereas the force on A will be from left to right.
Yes, sir.
Force on B due to A, pulling, is right to left. Force on A due to B is pulling left to right. Clear?